A ghost has entered our solar system, an icy wanderer from another sun, trailing a halo so immense it could nearly stretch to the moon if placed above Earth. This is 3I divided by Atlas, only the third confirmed interstellar visitor in human history. Discovered in July 2025, it has already surprised us. NASA's James Webb Space Telescope detected carbon dioxide pouring from its surface at an unprecedented ratio, 8 molecules of CO₂ for every 1 of water, while SPHEREx mapped a coma hundreds of thousands of kilometers across. And yet, at the very moment it draws nearest to the Sun, Earth, what if the most extraordinary event in our solar neighborhood this year will happen right where we cannot see it, hidden in the Sun's glare, invisible to the naked eye? A cosmic traveler from another star, wrapped in a glowing shroud nearly the size of the Earth-Moon distance, is about to skim past our Sunday. Its name is 3I divided by Atlas, and it is only the third confirmed interstellar visitor ever found. Welcome, my friends, to Velocity of Comets. I invite you to stay with me as we unfold its story, not with alarm, not with hype, but with wonder and with evidence. The paradox that draws me in is this: at its closest point to the Sun, when it burns brightest and most alive, Earth will be on the far side of the solar furnace. Its most dramatic act plays off stage. And yet, thanks to our instruments, we already know what makes this traveler so unique. NASA's James Webb Space Telescope and the upcoming SPHEREx mission have revealed something astonishing. 3I divided by Atlas is dominated by carbon dioxide, not water, a ratio of about 8 molecules of CO₂ for every 1 molecule of H2O. That balance is far outside the range we see in typical solar system comets. SPHEREx measured its coma, extending at least 348,000 kilometers, so vast that if you place the nucleus on Earth, its shroud would nearly touch the moon. Imagine standing on the surface, looking up, and seeing the moon embedded inside that breath of gas and dust. That's the scale we're talking about. Step into the dome with me. The night air is cold and dry. The telescope's gears hum as the slit opens and the mirror begins to track. On the screen glows a rainbow stretched thin, every color pulled apart by Webb's spectrograph. At 4.3 microns, the line jumps. That's carbon dioxide exhaling into space. Nearby, faint traces of water and carbon monoxide trail after it, but CO₂ is the loudest voice by far. And here's the strange part: it's happening now, when the comet is still far from the Sunday. Most comets slumber until they slip inside Jupiter's orbit, when sunlight can thaw their water ice. But carbon dioxide boils away at colder temperatures, so this comet has awakened early, billowing a massive coma out beyond the orbit of Mars. Walk outside with me for a moment. The sky is dark, and the stars are sharp. The same dome of sky once sheltered Voyager 1, as it turned back for its family portrait of the planets. The same sky gave us the Hubble Deep Field, revealing a universe packed with galaxies where our eyes saw only blackness. Today, James Webb peers even farther, capturing galaxies as they were when the first stars lit up. And now those same instruments are turned on a single traveler, an ice-rich rock from another sun, passing through our system only once. It is humbling, almost intimate, that we can read its chemistry across light years. And the questions spill out. Where was 3I divided by Atlas born? Did it form in a disk where the snow line for CO₂ sat closer to the star than waters, stacking the comet with carbon dioxide? Did radiation in a harsher part of the galaxy cook its surface into a crust, letting CO₂ vent while water stayed buried? Or is this simply its outer skin, and deeper down it hides the same balance of water and carbon we see in our local comets? Any of these answers would mean something profound about how planets and comets form across the galaxy. Now imagine its path. Lay the solar system flat, like a sheet of glass, with the planets spinning around on wires. 3I divided by Atlas approaches on a hyperbolic arc, a one-time swing by. It bends toward the Sun, accelerates to nearly 70 kilometers per second, and then is gone forever. The tail streams out, always pointing away from the Sun, a windsock in the solar storm. At perihelion on October 29th, Earth will be hidden on the opposite side of the Sun, so we will see nothing. But by early November, it will rise again in dawn skies, faint but traceable. The paradox continues. The moment of greatest activity comes when we cannot look, and we must be patient to see what follows. Patience, though, has its rewards. the transiting exoplanet survey satellite, built to hunt for planets accidentally photographed 3I divided by Atlas months before its official discovery. When astronomers went back and stacked those images, the faint glow of activity was already there. This is what I love most about science. Tools made for one purpose end up revealing another, if we are curious enough to notice. And a reassurance, this comet is no threat. Its closest approach to Earth is nearly 270 million kilometers. It will skim past Mars's orbit, brush past Jupiter on its way out, but Earth is entirely safe. Its story is not about danger, it's about knowledge. Each new dataset, each telescope pointed toward it, is a line in the biography of a traveler we will never see again. So, here's my invitation. Stay on this journey with me. Subscribe, comment, share what you most want to learn. Its birthplace, its chemistry, its role in shaping planets. Together, we will follow this wanderer through perihelion's glare and back into the night, learning what it tells us about other suns and about our own beginnings. The galaxy is opening its doors, sending us samples. And if you have ever stood outside on a cold morning, seen your breath drift white against the dark, you already know what this comet feels like. It is breath, ancient breath, carried across the stars, now mixing with ours for a brief and unforgettable moment. Would you like me to continue with rewriting Part 3 inches, the same style, engaging, emotional, and fully aligned with the structure? Do you still feel the pulse from Part 1? The awe of standing beneath that vast CO₂ halo stretching almost to the moon's orbit? Hold on to it, because now we dive deeper, where the numbers themselves begin to whisper stories. This is where curiosity sharpens into analysis, and wonder matures into insight. When NASA's James Webb Space Telescope trained its near-spec instrument on 3I divided by Atlas in August 2025, it did what Webb does best: turned invisible light into visible truth. Across the spectrum from 0.6 to 5.3 microns, the signature of carbon dioxide shone like a flare. It wasn't a trace element, not a subtle seasoning in a soup of water. It was the dominant ingredient. Outgassing streamed sunward, as if the nucleus itself were exhaling toward the star. Alongside it, faint but clear, were the fingerprints of water vapor, carbon monoxide, carbonyl sulfide, and a sprinkling of ice and dust. But the ratio, the part that stops you cold, was 8:1. 8 parts CO₂ for every 1 part H2O. In our own solar system, most comets tip the balance in the other direction, their tails fueled by water. Here, carbon dioxide holds the reins. The deviation is so sharp, so unlikely, that astronomers calculate it sits 6 standard deviations above normal. That's not noise, that's identity. And SPHEREx confirmed the enormity of it. Its wide-field mapping showed the CO₂ coma ballooning to 348,000 kilometers. Let that sink in. If Earth were the nucleus, that gaseous halo would graze the moon. A single speck of ice, adrift from another star, carrying a cloak big enough to rival our planetary neighborhood. The data tell us this is no ordinary comet. Why such a strange composition? 3 main hypotheses emerge. The first is birthplace physics. Imagine a young star encircled by a disk of gas and dust. Every volatile has a snow line, a place where temperatures fall low enough for molecules to freeze. Water condenses closer in, carbon dioxide farther out. If 3I divided by Atlas formed near the CO₂ snow line, it would be stocked with ices that start to sublimate at much greater distances from the sunday. That could explain why it woke early, glowing long before water ice ever stirred. The second is radiation history. Perhaps this comet spent billions of years in a harsher environment than ours, maybe circling a star deeper in the galactic disk, soaked in ultraviolet light or cosmic rays. Over time, its surface could have hardened into a crust that locked away water, while cracks and pores allowed CO₂ to seep out. To us, it looks like a comet built of carbon dioxide. In reality, it might just be wearing a mask forged by time and radiation. The third is thermal skin depth. Right now, only the topmost layers of the nucleus are warmed by sunlight. If those layers happen to be rich in CO₂, then the early activity is biased toward that gas. As the comet swings closer to the sun, heat will penetrate deeper, possibly liberating water. If the ratio shifts in the months ahead, it will tell us about layering and history locked beneath the surface. Of course, science thrives on counterpoints. Could these readings be illusions? Could Webb or SPHEREx have misread the spectrum? The answer lies in the chorus. Both instruments, designed and calibrated, independently sing the same tune. The CO2 band, near 4.3 microns, is well understood, and the signal is strong. Two telescopes, one conclusion. The odds of error are slim. Could we be simply catching an oddball, the way Comet C/2016 R2 in our own system also carried unusual amounts of CO2? Possibly. But each outlier widens the horizon, reminding us that comets are not monolithic. They are as diverse as the kitchens where they are baked. Dynamics reinforce the natural story. The orbit is hyperbolic, an open arc, not a closed ellipse. 3I divided by Atlas will not return. At perihelion, on October 29th, it will pass about 1.4 astronomical units from the Sunday. Earth's distance will remain a safe 1.8 AU, nearly 270 million kilometers away. No threat, no danger. Its trajectory may align roughly with the plane of the ecliptic, but models predict that 10 to 20% of interstellar arrivals should do so by chance. That's not steering, it's statistics. And NASA has been clear, this is a natural comet. Wonder doesn't need conspiracy, it thrives on evidence. Even before discovery, other eyes had caught it. The Transiting Exoplanet Survey satellite, TESS, built to watch for planets crossing stars, had unwittingly imaged 3I divided by Atlas in May and June. When astronomers later stacked those frames, the faint point of light emerged, already active, a comet telling its story months before we knew to listen. That, to me, is the poetry of astronomy, tools designed for one question answering another. Still, there is irony in the timing. At perihelion, when the comet blazes brightest, it will be invisible from Earth, lost in the sun's glare. Our next good look will come in early November dawns, when it re-emerges in the morning sky. By December, telescopes may capture its fading glow as it retreats past Mars. Each observation will refine the picture, showing whether water joins the show or whether CO2 keeps the stage. And when we step back, we see the bigger arc. First came 1I, ʻOumuamua, enigmatic, no coma, and a mystery acceleration. Then 2I divided by Borisov, a comet more familiar but laced with unusual chemistry. Now 3I divided by Atlas, dominated by carbon dioxide, unlike either of the others. 3 messengers in less than a decade, each one unique. That's not an accident, that's the galaxy reminding us that planetary systems write many stories, and sometimes they send us chapters to read. It leads to one last question. Could we ever go meet one of them? SPHEREx scientists have sketched mission concepts, showing that with the right architecture, rapid detection, rapid launch, an interceptor spacecraft could catch an interstellar visitor for a brief but priceless flyby. Juno cannot be repurposed. The relative speeds are simply too high. But if we build for the challenge, if we prepare now, the next wanderer could be more than a streak in the sky. It could be a face-to-face encounter. For now, we wait, watch, and learn. 3I divided by Atlas is our teacher, its lesson etched in CO2 and silence. And in every spectrum, every map, every late-night vigil at the telescope, it tells us the same thing. The universe is more varied, more surprising, and more generous than we ever dared assume. Would you like me to now rewrite Part 3 with the same engaging depth and resonance, carrying the arc into climax, meaning, and future? Here is where everything comes together, the place in our journey where evidence turns into revelation. For weeks we've traced numbers and spectra, plotted paths and ratios, but now the curtain lifts. The astonishing truth about 3I divided by Atlas is that it is not just another comet, it is a messenger carrying the memory of a world we have never seen. Its chemistry, its size, and its trajectory are telling us that the universe builds with many recipes, and for the first time, we are tasting one of them. The reveal is simple but profound. An interstellar comet dominated by carbon dioxide, its CO2-to-water ratio around 8:1, its coma ballooning to nearly 348,000 kilometers. Imagine how different its nursery must have been. While comets in our solar system are mostly water-driven, 3I divided by Atlas is a dry ice giant, active long before the sun's warmth could rouse a normal comet. That single fact rewrites our assumptions about planetary formation across the Milky Way. It means some young systems may stockpile volatile gases in places where ours stored water. It means planets born in such systems could have very different climates, very different chances at oceans or atmospheres. One wandering comet has expanded the range of possible worlds. Think of the consequences. This is no longer a thought experiment about diversity in protoplanetary disks. It is a measurement. Carbon dioxide, water, carbon monoxide, exotic ices, all present in a balance we had never seen before. These molecules are the architects of atmospheres, the shapers of climates. They are also the couriers of organic chemistry, the potential seeds of habitability. If comets like 3I divided by Atlas roam between stars more often than we imagined, then the galaxy is not just exchanging rocks. It is exchanging ingredients for life. And what of the mystery of its origin? Somewhere, billions of years ago, a disk of dust and gas swirled around a star we will never name. There, near the line where CO₂ froze, this body assembled, layer by layer, ice by ice. Perhaps a passing star nudged it free. Perhaps a nova blast shook it loose. Whatever the cause, it was exiled into interstellar darkness. For ages beyond counting, it drifted cold and unseen, until chance aligned it with our Sunday now. For a few fleeting months, it breathes in our light, and then it will be gone forever. That alone is enough to inspire awe. But there's more. This is the third interstellar visitor in less than 10 years. In 2017 came ʻOumuamua, with its eerie, cometless path. In 2019 came 2I divided by Borisov, a comet more familiar yet chemically strange. Now in 2025, 3I divided by Atlas brings us a new category, a fully active comet, but one defined by CO₂ rather than water. 3 objects, 3 different faces. The pattern is clear. Interstellar visitors are not rare quirks, we just lacked the eyes to see them. With Atlas, Pan-STARRS, and surveys like Vera Rubin Observatory soon online, we are stepping into an age where such encounters may become routine. What seemed miraculous is about to become normal. The future stretches in front of us. Already, mission designers are sketching plans for ISO interceptor spacecraft that could launch on short notice and meet the next wanderer head-on. The Southwest Research Institute has shown that such missions are possible. Imagine the day when a spacecraft races across space to fly within a few hundred kilometers of a fresh interstellar comet, imaging its surface, sniffing its gases directly, sampling dust grains forged around another Sunday. That would be more than a flyby. It would be first contact with the building blocks of alien worlds. NASA's clear statement that 3I divided by Atlas is natural, not artificial, grounds us in reality. But that does not diminish the wonder. Wonder does not need conspiracy to thrive. The thrill lies in the data themselves. A comet brighter, larger, and stranger than the ones we grew up with. One that confirms the galaxy is a house with open doors. It is not sealed, not isolated. Stars and their leftovers mingle, share, and sometimes pass through each other's front yards. We are learning this by watching a single speck of ice and rock slip across our sky. So where does that leave us? It leaves us with a new humility and a new ambition. Humility, because the cosmos is showing us just how little we knew about the diversity of worlds. Ambition, because we now know we can detect them, track them, and one day chase them. Perhaps the next interstellar comet will be water-rich, perhaps carbon-rich, perhaps something we cannot yet name. Each will widen the circle of possibility. Each will sharpen the story of how planets and life can arise. And now, I turn the question back to you. If you had the power to choose, which kind of interstellar object would you want us to intercept? First, a silent shard like ʻOumuamua, a classic water-driven comet like Borisov, or another wild CO₂ giant like 3I divided by Atlas? Your answer matters, because science is not just the work of institutions, it is a shared voyage of curiosity. Stay with me on this channel, Velocity of Comets. Subscribe, share your thoughts, and join the fellowship of those who refuse to let awe pass them by. Together, we will follow every visitor, every spectrum, every unexpected chapter the galaxy writes in our sky. Because one truth is now certain, interstellar messengers will keep coming. And if we listen carefully, they will keep teaching us who we are, where we come from, and where we might yet go. Now the story of 3I divided by Atlas bends toward its close. It came to us not with noise or spectacle, but with data clean, startling, unforgettable. A CO₂-dominated comet, active far from the Sun, with a coma so large it could envelop the Earth-Moon system. Its chemistry stands as a bold reminder that our solar system is not the template for all creation. In some nurseries, carbon dioxide, not water, may write the first lines of planetary destiny. And yet, there is a quiet poetry to its journey. Long ago, some cosmic shove tore 3I divided by Atlas free from its home star. For untold millennia it drifted in silence across interstellar space, until at last chance steered it here. We, with our telescopes and curiosity, became the brief witnesses of its passing. For a handful of months we can read its breath, measure its light, and imagine the world that shaped it. Then, it will be gone forever. What strikes me most is what this comet says about us. A century ago, we might never have known it was here. Today, space observatories on Earth and in orbit catch its faint glow and decode its spectrum. We are no longer blind, we are participants in the great exchange of galactic stories. Each visitor enlarges our understanding of what is possible and what may already exist beyond our reach. So I leave you with a question. If the galaxy sends us another traveler tomorrow, what would you most want to learn: its chemistry, its birthplace, or whether such objects might one day seed life between the stars? Share your thoughts and subscribe so we can keep following these messengers together. For the universe is not closed, it is porous, alive with motion. And in every fleeting visitor, like 3I divided by Atlas, we are reminded that the cosmos still has secrets left to share.